So we are on the CEC Gurukul lecture and we are in the series of electronic circuit. In the electronic gadget, one important gadget is the heater. So today we will discuss the electric heater, how it is constructed and what materials we use in the electric heater. So today we will discuss about the heater. Basically heating is achieved by using a resistor in the electronic circuit. Within an electric circuit, this resistor has few free electrons, so it does not conduct electricity easily. As electrons encounters resistance, it is generated, which provides the energy needed for the electric devices to function. So although electric heating is highly efficient, so it can be costly due to the high amount of electric energy required. So electricity is more expensive as compared to the energy sources like water, gas and fossil fuel. However, the electric heaters often have lower purchase and installation costs, making them attractive to the buyer. For domestic use, electric heaters are typically insulated with the plastic material to prevent the electric shock and reduce the energy losses. So electric heater is a very important part in the electronic gadget whenever we require the heating in the electronic circuit. So design of an electric heater. That electric heater consists of a heating core that warm up when an electric current flows through it. So there are two main types of heating cores used in these devices. First is the oil filled core and second is the dry cores. So some heater uses the dry core, some heater uses the oil core. So in the designing of the electric heater, dry cores typically made from the ceramic, and these are lightweight and these are leak proof. These ceramic radiators are energy efficient and excel at retaining heat, which enhances their overall effectiveness. So the radiator's outer body is usually constructed from aluminum or steel, which aids in energy dissipation. And apart from that, the oil filled radiators contains oil that is heated to provide warmth, and it does not require refilling throughout the product lifespan. The thermal liquid inside the radiator remains effective for the duration of its use. So we use the dry heater as well as we use the oil heater. Apart from this, resistor coils in these heaters can either exposed and mounted in insulator, embedded in refractory insulation with a metal enclosure. All these are enclosed in a metal chamber or enclosed in a glass case within a printed circuit. So additionally, the radiator features finds that enhance heat dissipation by increasing the surface area. All the electric heaters have a heating element, that is an electrical resistor. Means all the heaters having a electric heating elements, and that are the electric resistor. It means every electric heater have the electrical resistor that has the heating element. They work on the principle of Joule's law. And these are electrical resistors which converts the electric energy into the heat energy by emitting radiant energy. So resistors may be made up of the metal alloy, wire, non-metallic, carbon compound or any printed circuit. Nowadays we are using the printing electronics. So these circuits are designed by using the printing the circuits on the paper, on the PCB board or in any other substrate. So the resistors, these electrical resistors converts the electrical energy into the heat energy by emitting radiant energy. So resistors are made of the metal alloy wires. Modern electric devices use nichrome metal as heating element. The electric heaters use nichrome metal wire as active elements with ceramic insulation. And now before going ahead regarding the electric heater, we discuss the heating element, which is the most important part of the electric heater, which is basically resistor, which converts the electric energy into the heat through a process that is called the Joule heating. So, heating element use the principle of the Joule heating. Joule heating occurs when an electric current flows through a conductor, causing electrons or charge carriers to collide with the conductor's atoms or ions. You see on the screen, here we are having a heating element. This is a simple element, heating element. This is a simple device which use these collisions generate frictions at the atomic level. Where we are having a collision as the Joule heating occurs when an electric current flows through a conductor and causing the electron charge carriers to collide with the conductor's atom or ions when an electric current passes through the conductor. These collisions generate friction at the atomic level and which is experienced as a heat. Because of this collision, it generates the heat. The amount of heat produced by this process is described by the Joule's first law, that is also called the Joule-Lenz law, that can be expressed as P is equal to IV, or we can write it as P is equal to I square R. That is amount of heat generated. According to these equations, the heat generated depends on the, as it is P is equal to IV, so it depends upon the current as well as on the voltage, resistance of the conductor, as well as we are having the P is equal to I square R, it also depends upon the resistance. So when the designing heating element, the resistance of the conductor is a crucial factor. So, in keeping the resistance, we prepare the heater accordingly. Joule heating occurs at all conductive materials to varying degree except in a superconductors. So, if we talk about the material with the low electrical resistance produce the less heat. If the material having a low electric resistance, so if we require the high heat, then we use the high electrical resistance material. So, because charge carriers, why materials with the low electric resistance produces the less heat? It is because the charge carriers flow more easily through them, whereas the material with the high resistance generate the more heat. Means low electrical resistance produces the less heat, more resistance, high resistance generate the more heat. So, it is inversely. So, in general, the material with the low electrical resistance produce the less heat because the charge carriers flows more easily through them, whereas the material with the high resistance generate the more heat. Superconductors allows the electric currents to flow without producing any heat. Typically, the heat generated by the conductor is considered as the energy losses. So, electrical energy used to power equipment often results in unwanted heating known as the copper loss and does not contribute to the useful work. As the power equipment often result in unwanted heating, so that is the copper loss or that is not useful. Electrical heating elements are nearly 100% efficient in converting the electrical energy into the heat, as virtually all the supplied energy is transformed into the thermal energy. The supplied energy, that is in the form of the current, electrical energy, that convert into the thermal energy. These elements may also emit energy in the form of light and radiation. So, however, the efficiency is ideal only for the resistors. So, the heating elements may also emit the energy in the form of light and radiation. Small losses also occur due to the material inherent capacitance and the inductance, which converts the electrical energy into the electric and magnetic field respectively. So, additionally, overall system efficiency can be affected by heat dissipation into the external environment from the process fluid or the heater itself. Therefore, to maximize the utilization of the generated heat, the heating system must be well insulated. It means for avoiding the dissipation of the heat, so the heating system must be well insulated. What material we use in the heating element? So, we discuss the materials are used for heating element. The most commonly used material include nickel, chromium alloy, iron chromium, aluminum alloy, molybdenum silicide and silicon carbide, all which are suitable for the high temperature applications due to their resistance to oxidation. So, these material are used as a heating element in the heaters. So, another category if we talk about is the graphite, molybdenum, tungsten and tantalum are used for the heating element. These materials are prone to the oxidation at elevated temperature and are therefore typically used only in the vacuum environment or the furnaces where the atmosphere is free from the oxygen. So, graphite, molybdenum, tungsten, these materials are the prone to the oxidation to elevate the temperature and they are typically used for the vacuum environment. As you see in the vacuum chambers, you will see these material only, and just we use the furnaces in the laboratory, then all these uses these type of elements. So, where the atmosphere is free from the oxygen, we are having the vacuum in it. So, what are the properties of the heating element? When we choose the heating element, we just find out its properties. So, nearly all conductors generate the heat when an electric current passes through them. However, not all the conductors are suitable for the use as a heating element. So, the ideal heating element material must possess a specific combination of electrical, mechanical and chemical properties. So, the following are the key properties essential for the effective heating element device. So, what are the properties which are very important in choosing the heating element? First is the resistivity. So, to produce the heating element must have enough electrical resistance. As we see that low resistance means high heat. So, if we want to produce the high heat, so we require a suitable amount of the resistance. So, to produce the heat, the heating element must have the enough electrical resistance. However, the resistance must not be so high that it becomes an insulator. So, electrical resistance is equal to the resistivity multiplied by the length of the conductor and divided by the conductor cross section. So, whenever choose the resistivity, so electrical resistance is equal to resistivity multiplied by the length of the conductor divided by the conductor cross section. For a given cross section, to have a shorter conductor, a material with a high resistivity is used. You see on the screen, that is the R is equal to rho L by A. So, resistance as a function of resistivity, as a function of length and a function of cross section area. So, you can see that how we choose and how we take the heating element on the basis of resistivity. Another important point is the oxidation resistance. Heat generally accelerates oxidation in both the metals and ceramic, as we know that we use this material. So, oxidation can consume the heating element, which can decrease the capacity or compromise its structure. So, this limits the life of heating element. for metallic heating element, alloying with an oxide former helps in resisting oxidation by forming a passive layer. For ceramic heating elements, protective oxidation resistant scales of SiO2 or Al2O3 are most common. Means in the ceramic heating, we use the silicon oxide and aluminum dioxide, we use it, and the metal heating element alloying with an oxide former helps in resisting oxidation by forming a passive layer. So, for oxidation resistance in both the metallic heating and the ceramic heating, we use the different elements. Another important point is the temperature coefficient of the resistance. As we use the resistance as a heating element, so resistivity of the material changes with the temperature, as we know, and in most conductors, as the temperature increases, resistance also increases. This phenomena has a more significant effect on some material than others. So, a higher temperature coefficient of resistance is mostly used for heat sensing application. A higher temperature coefficient of resistance is mostly used for heat sensing application. For heat generation, it is usually better to have a low value. So, as if we use the temperature coefficient of the resistance, so we should have a low value, forget the high heating. So, another property is the mechanical property. Rigid heating elements can deform when used at high temperature. So, as the heating elements, the temperature will change. So, if it is a high temperature, the deformation will be created if it is a rigid heating material. So, material approaches its molten or recrystallization phases, the material can weaken and deform more easily as compared to its state at a room temperature. So, we choose the element in such a manner so that it should not be rigid towards the heating. So, a good heating element can maintain its form even at high temperature. On a different note, if we talk about the ductility is also a desired mechanical property. Especially for metallic heating element, ductility enables the materials to be drawn into the wire and form its shape without compromising its tensile strength. Another point when we are choosing the heating element is the melting point. Aside from the temperature where the oxidation significant increases, the material's melting points also limits its operating temperature. So, ceramic generally have higher melting point than the metallic heater. So, we have to keep in mind whenever we choose a ceramic, because it is having a high melting point than the metallic heater. So, we choose such materials which is having a high melting point in the ceramic cases. What are the types of wire in the electric heater? As we discussed right now, that what are the properties of the electric element. So, now what type of wire we can use in the electric heater? As electric heater is made upon the wire or element, or you can say that it is a heating element. So, what type of heating element we can use in the heater? So, there are generally three types of electric resistance heating wire that are used in the modern resistor. Number one is the open wire. You see on the screen that this is a very simple open wire which consists of the nickel chromium resistance wire, which is mounted on the ceramic or mica insulation. As you have seen, mostly ceramic type of heater where this wire is also attached. So, it is this type of nickel chromium resistance wire which is mounted on the ceramic or the mica insulation. Proper protection of this wire is crucial. So, as direct contact with the wire by user or the metal objects can result in the severe electrical shock. So, we have to very careful whenever you use the open wire. Next type of wire is the open ribbon wire. This ribbon wire is similar in the material to open wire, but features a large exposed surface area. So, this increased exposure heightens the risk of the electric shock if it comes into the contact with the object or the individuals. Another, which is the most commonly used, is the tabular cased wire. This tabular cased wire consists of nickel chromium resistance wire and cased in a layer of magnesium oxide powder, and which is then enclosed in a heat resistant steel tube. You see on the screen, this is a one type of the tubular cased wire, and these wires are used in the electric heater. This construction provides the protection against the electric shocks and enhances durability, so ensuring a long lasting performance. So, this tubular cased wire are the very much giving a high performance. So, what are the working of the electric heaters? Electric heaters operate based on the Joule's law, as we discussed, and they consist of the electrical element that generate heat to warm the heater's core. As all the heater having a core, so we have to warm this heater core. When an electric current flows through the resistors within the heater, these resistors heat up and release energy as a heat, and this heat dissipates into the surrounding areas, warming the core of the heater and achieving the desired temperature throughout the space. So, the electric current passes through the resistors, charges the cathode in the electron tube and resulting in the production of the heater. This is the working of the electric heater you on the screen. They are the other parts, cathode and anode, which are used for the, which is resistors. Through the resistors it is charged, so it is used for this. What are the modes of the heat transfer in the heaters? There are the three types of modes which are used to transfer the heat into the heater through the heating element. Number one is the conduction, second is the convection, and third is the radiation. These are the three modes of the heat transfers in the heater: conduction, convection, and the radiation. We will discuss further these type of methods in the next lecture. Thank you very much.